Hello, welcome to Derivatives 5. Today we're just extending what we've done so far and doing two topics, maybe three topics, we'll see. But implicit differentiation, which involves something called y prime, but it'll be in the middle of the equation. And then we're going to be doing higher order derivatives, which means just getting the derivative more than once on the same function. If we have time, we'll get to tangent lines, which we've already done actually, but we'll see how time goes. Very importantly, the final, which is the final test, not really a final exam, it's a 10-question multiple choice test, different for everyone, is next Saturday, June 20th, 8 o'clock in the morning. All right? So get that in your head, write it in your calendars, make sure you know where it is on D2L. That'll be the date for the test. Everyone has the test at the same time. Okay, all Math 1101 students have the test at the same time. I think that's pretty much it for that. We'll finish this unit tomorrow. We'll have the assignment on Wednesday. I might give you more than half an hour for that. I might actually give an hour. On Thursday, I'll do a little bit of review for the test if you want it. And then Sunday will be the test. After that, we'll be doing Unit 6 on Monday, Unit 7 on Tuesday, and we'll be hopefully done the course. If we don't finish on Tuesday, we'll finish on Wednesday. All right, so let's get started today. We're starting a little bit late today because I had a couple latecomers, but we'll still get done what I want to get done. Okay, if you have any questions, just let me know as always. So the first topic today is called implicit differentiation. And this word implicit means that we can't get our derivative like we normally would. We have y values in the middle of our equations. So it says here, there will be times when we're not able to solve for y explicitly, which means we can't solve for y. We can't get something that's y equals. We can't get y equals exactly. So let's look at this expression. You see this. You can see that there's a y to the power of 5 here. There's a y squared inside, and so on. It's not solved for y to begin with. So in other words, normally we have something like y equals 5x squared plus x, right? And we have x's and just x's. But today, we're going to be seeing more things like y plus 5xy equals 3. That's not already solved for y. Thankfully, it's actually pretty easy to do. So I'll explain that now. It says we're unable to solve for y. We're unable to get an expression where y equals f of x or y equals our function. That's because we can't get a fifth root very easily. It says in this case, I don't know why my computer is freaking out so much today, so hopefully it's not too loud. Such a function where y is defined implicitly as a function of x is called an implicit function. What this means is our function y, our value y, our variable y, is actually a function of x. So we're going to do the chain rule. Let me just get to the point here. The derivative of y with respect to x is this. So I'll do the first example so you see what I mean, see what the difference is between what we've been doing. I don't want to over-talk it. So I'm going to write this over to the side. It's done already, but I want to make a point here. Okay, let me just go over to the side here. We need to get the derivative, dy by dx. All right, so let's just do it one piece at a time. We'll get the derivative. What's the derivative of x? Hopefully you know this very clearly now. It's 1, exactly. It's just 1. What's the derivative of y? Well, the derivative of y is y prime. You can also write it as dy by dx. And that equals 2. So the problem is we're actually trying to get this. That's our derivative of y. dy by dx, that is y prime. It means the same thing. So what we do, we just solve for that. And we solve for it the way we normally do. Bring the 1 to the other side. What this gives us, it means that dy by dx is 2 minus 1. Or in other words, dy by dx equals 1. Sorry, 1 second. I'm just looking at my, what have I done? Looks like the answer says, oh, I made a mistake already. It's going to be one of those days. this is not 2. The derivative of a constant is 0. So that was a silly mistake on my part. We're going to bring the 1 to the other side now, solve for dy by dx, we get -1. So that was my mistake. That 0 there is because the derivative of a constant is 0. So the derivative of x is 1, derivative of y is dy by dx, or y prime. Derivative of 2 is 0 because it's a constant. Solve for dy by dx. And that's how we do these things. They're a little trickier normally, but I wanted to start simple. So in short, if you have a y, the derivative is just y prime, if it's y on its own. Sometimes it's a little different. I want to make a note. What if we rearrange first? So if we rearrange first, we have x plus y equals 2. Let's solve it for y first. So let's bring the x over here. We'll end up with y equals 2 minus x, and then get the derivative. So the derivative of this, dy by dx, well, what's the derivative of 2? It's 0. I'll write that out again. What's the derivative of negative x? It's -1. And so that would simplify down to give -1 again, which shouldn't be a surprise. They're the same. That means that we can use either strategy. If you can solve for y first, go ahead. If you can't solve for y first, which is usually the case, we need to do implicit, which means it's in the middle of the equation. And that's actually not usually that difficult to solve. Okay, so that's what this example is trying to say. That's this example 1. So we just did that. It's giving these 2 answers, and they end up giving the same. So let's look at the next example, which is a little trickier. I'll leave that there so you can look at it. It says find the derivative dy by dx, and I'm going to make a note here. Dy by dx, same thing as y prime. So you can go ahead and just call it y prime if you want, of this function. We can't solve that for y. I mean, we could, but it would be a square root, and we'd only be getting half the function. So we'll just do it directly. So let me show you what happens here. This y, all right, is actually a function of x. So we need to do the chain rule. What I mean by that is, let me just show you. I'll put it down here, y squared. If I want to get the derivative, I take the 2, I bring it down in front, and then I reduce it by 1, yeah? Sorry, my computer is fighting with me. Just give me a second. So that the derivative here would be 2y, and 2 minus 1 is 1, so you don't need to write it. And it actually pops out a new value, just like we do the chain rule. Do the chain rule of this. What's the derivative of y? It's actually y prime. So we get a little extra thing. If you see a y, you can treat it just like an x. So look at this. This one here. What's the derivative of that? If it were x, what would be the derivative? Well, the derivative would be 2x. So we'll say 2y. But we get a new term because of the chain rule. We brought the 2 down, kept the y, and now we get the derivative of y, which is y prime. Right, so I'm going to move that up a little bit. So that's how these things work. That's a new term. Be careful. That purple color is our new step. That's what comes out of this. What's the derivative of 2x squared? Well, the 2 comes down, multiplies, 4x. We did lots of that yesterday. And the derivative of 5 is 0. All right, that is not solved. We're not at the end of the question. What do you think I need to do next? If I'm looking for dy by dx, which is y prime, what do I need to do? Well, solve it like any variable. Y prime is just like x or a y or a z or an a or a b or a c. Solve for it like a variable. So let's bring this to the other side. We'll end up with 2y times y prime. And I'll keep the y prime, our purple color, just to remind you that that's what I'm looking for, equals -4x. I'm going to make more space to the right here. I'll go one more step. What do I need to do? I need to divide both sides. So if If I divide both sides, that means y prime will be equal to negative 4x over 2y, and we can simplify that. Y prime is negative 2x over y. And some students wonder why. Well, this is just, of course, this is a 2, this is a 1, so it's 2 over 1, or 2x over y. And we have a answer that we've actually never seen before. We've never seen something like this. We've never seen a y in our final answer before. And that's because we've never done implicit. Implicit means there's a y inside its own derivative. It just looks a bit different when we graph it, but we won't even need to worry about what it looks like. We just need to be able to get it. And what this turns out that it is, if you look at the original equation, this is actually the derivative of an ellipse. So the derivatives are going to be a little bit crazier than our regular functions. So that's the strategy. Can you just let me know if there's any steps you want me to go back over? No? Okay, Abdullah says no. Anyone else have any issues with that? Basically, it's the first step, I think, is the trickiest step. You need to make sure that you don't forget y prime. So before we move on, I'm seeing in the chat that you're doing pretty well. I'm going to make a note on the side here. Just want to find some space for my little workings. Just want to make some notes on derivatives. I don't know what happened there. My computer sometimes fights me. The derivative of 2x is 2. The derivative of 2y is 2y prime. The derivative of 2x squared is 4x. The derivative of 2y squared, because y is a function of x, the 2 would come down, multiply it. I would keep the inside the same, the inside here being our y, and I need to pop out a y prime, because whatever that y is, it's some function of x. We don't know what it is. It pops out a y prime. So that's the big difference. Notice that every time we have something as a function of y, we need to get a y prime term at the end. So when getting a derivative of y, needs a y prime at the end, or next to it. That's kind of my tip to you, all right? That's my piece of advice. Let me just clean this up a little bit. As long as you know what I'm talking about now, as long as you're clear on that rule, on that tip, you should have no issue with this section. We're just going to get our derivatives, and then we're going to solve for that y prime, just like any variable. Okay? So if you want me to come back to these notes, I'll come back to it. But for the meantime, I'm going to move on to the next example. Let's see what we have. Find dy by dx. I'm looking at this. Find dy by dx if this is our function. Now, first of all, if it were an easier function, we would want to solve that for y. But look here, we have a y to the power 4, we have a y squared. There's no way we're going to get y equals something. We're not going to be able to solve for that y. So we need to do it implicitly. So let's see if we can do this together. The first term, let's see. I'm going to do the first term, 3y to the power 4. So the 4 comes down, multiplies by 3. That's 12y cubed. And then remember, if you see a y value, it pops out this y prime. I don't even need to put the dot there, really, but I like to put the dot there so that you don't forget about it. So times y prime. Not times y prime. And now the next one, xy, that one's actually tricky. Many students, and I wouldn't write this down, just follow me here. Many students look at this and they say 1, 2y, y prime, because they see the x and they make the derivative 1, and then they see the 2y and they make that 2y, y prime. But that's not correct because this is a product. So this, we need product rule for this. So let me move this down so that I give myself a little bit of space to work on it. The product rule is the derivative of the first one, 1, times the second one, plus the first one, x, times the derivative of the second, y prime. So let me show you. First, second. This is why I reviewed this yesterday. Make sure that we're all on the right page. Derivative of the first one times the second plus the first one times the derivative of the second. Okay? Very, very, very important. If you miss that, you miss a significant amount of marks for the question. It'll make the question really easy, and then you won't be able to get all the rest of the marks. So you got to be really careful. Once we're done that part, the rest is pretty easy. What's the derivative of 2x cubed? 3 comes down, becomes 6, x squared. You have a question, Abdullah? No, okay. And then minus 6, well, a constant, derivative of constant 0, so this equals 0. So this is our first step.
Mister, I have a question, actually.
Yep, go ahead.
Why xy squared, we use the rule of 1g.
Why do we use
f prime g? Yeah.
Because if we look at this, it's xy squared. It's two different functions multiplied. It's the function x multiplied by the function y squared. X,
Okay.
if it's a y, if you see a y in there, that's its own function. We don't know what it is. We just know that it's a different function. Or think of it like it's a different variable. It's not a number, it's a variable. And they're multiplying each other. So it's now a product.
Mm-hmm.
So we need to use product.
It's not mean the x depend for y, or it's like any number for y?
No, we need to treat it like its own variable. And anytime you have two different variables touching, you've got to use product rule. That's the fastest way to think about it.
Okay.
Two different variables, you got to use product rule. End of the story.
Clear.
Okay. I'm just going to fix. So my pen is not being nice to me today, so I'm just changing a couple settings. But what we need to do now, we need to solve for y prime. I don't know why these are all changed. We need to solve for y prime because that's the actual question. So I'm going to need a bit more space. Once again, this book is frustrating. I'm going to just put the extra thing to the side. I'm going to solve. I'm going to take y prime out as a common factor here. So let's see if I can do that. I need to take it out. So I have y prime outside of 12y cubed. And I got to be really careful. 2xy. That's from this one. That's my common factor taken out. The other things, anything else, I'm bringing to the other side. So I'm bringing this to the other side. It'll be negative y squared. And I'm bringing this to the other side. It'll be negative 6x squared. So just to recap what I've done. I saw this, and I factored out the y prime and ended up with this. Okay? Take a minute to look at that, or if you need to, look back at the video. I've just taken the common factor of y prime out of those. Then I brought this one and this one over to the right side of the equation and made them negative. Now I just need to divide everything and I'll be okay. I'll be finished. All I'm doing is just dividing everything by this. So I'll bring it to the other side, okay? So that I have a nice clean final answer. I have negative y squared minus 6x squared divided by 12y cubed plus 2xy. So it looks like a lot of work. Honestly, it's actually not that much work. It's the same steps every time. Get the derivative, factor out the y prime, bring everything to the other side, divide. Okay, so I wish I had a bit more space for this question because they're bigger than it's letting me work with, but that's what I got. Any questions on this before I move on to a similar question next? No. Tu parles français, Abdelaziz, ou tu sais maybe peut-être un petit peu de français? Je ne pense pas que tu parles français. Il y a quelques personnes dans
Sir, can you repeat it again?
what, the French or the math part?
No, this part on the right, I don't understand it.
This part here, yeah. Well, all I'm doing is I've factored out. I'm looking at this and this. If you look at what's common, you have a y prime in common. So I brought it outside, and the rest is just what it is. If you can see that. I'm just leaving the 12y cubed there. I'm leaving the 2xy, which is really what that simplifies to. Just to be clear, 2y, x times 2y is 2xy. All right, so just to make those connections. Once I've factored it out, I'm just taking this whole thing and dividing it, putting it on bottom of the right side. Treat it like one big term and put it underneath the next one. You'll see the same thing happen again in the next question. And we have more space for the next question, thank God. All right, so we can come back to that if you need to, but for now I'll work on this one. I need the slope of a tangent line for the curve. Once again, every time I see this, I tell you the same thing. If we want to see the slope of the tangent line, first thing we do is get the derivative. The second thing is we're going to sub in whatever the given x value is, which in this case is going to be -3. But let's do the derivative first, okay? Because we want to worry about the simple stuff, or you want to do everything step by step. So the derivative, let me just write this down here. This is the original function. I just want it on the page so that we can work with it. So let me zoom in a little bit. I want the derivative of the first one. Can someone tell me in the chat what it is? Because this is the most important part, one of the most important parts of the question. What is the derivative of that first one? If it was 2x cubed, for sure it would be 6x squared. But it's 2y cubed, so what do we get? We get 6y squared, y prime. That's the big difference. It's not just 6y squared. Many, many students say it's just 6y squared. If we do that, we'll never have a y prime. So yeah, Abdulaziz, I see your little change there. The big difference, the huge difference is that y prime. You can't solve the question unless you're writing y prime when you do a derivative of y. Okay, so just be careful. So this is our derivative now. We'll do 6y squared. Once again, I'll put times y prime plus, and now once again, this is a product rule because we see two different variables, x and y. X, we're going to do a derivative like normal. If we do a derivative of y, we'll get the y prime. So I'll write all the product rule out in blue. Derivative of x times y plus x times the derivative of y, y prime. Plus 1, well, no, plus 0, so I won't write it, equals 0. So once again, I have a y prime that I need to work with, and we can solve for that. Okay, if you forget what product rule is, I'll write it one more time. F prime g plus f g prime. Fg plus fg, first, last, f prime. So let me write out what I've done. The first step here was get derivative. The second step, we'll factor out y prime. I'm going to factor out my y primes now. So I'll say y prime outside of 6y squared plus y. There's nothing to factor out there. Plus, there's really nothing to factor out here actually either. I'm sorry. I'm going to change my mind because I want to make this clearer for you. I think there's an easier way for you to see this. I'm sorry if you were writing that. I don't mean to do that. But sometimes it just happens. Bring all terms without y prime to the right, to the other side. And I'm sorry for making that change, but I really do think it'll be a small change that makes a big difference for you. So I'm going to bring this term to the other side because it doesn't have a y prime term in it. And that'll make it more clear to you why we're factoring. So we have 6y squared times y prime plus xy prime. And I've brought the this term here over to the right side. That'll be negative y. Okay? I've brought it to the other side and made it negative. It's still 1y, but I made it negative 1y, which is the same as negative y. Now that I've done that, now it's sometimes easier for students to factor out the y prime because you can see it here, you can see it here, and it'll be clear that it can be factored out as a common factor. So if we take it outside, y prime, we're left with 6y squared plus x equals negative y. Because when I factor it out, it kind of deletes that out, or it removes, it just leaves those, right? So, derivative, then brought all terms without y prime to the other side, and then I factored out y prime. Now divide. I'm going to divide by this one there. Divide both sides by that. We get y prime equals, it's going to be 6 y squared on bottom plus y plus x and negative y on top. So this is the same process as I used above. So I'll keep them both there so we can compare them.
الجيت وصل.
Say again. Say that again. What did you say? Can you hear me? I'm just wondering what that was. Did you have a question for me? Dad. Who's Dad? My voice? What's that? Oh, the students. As long as you can hear me. Okay, so we did the derivative, we factored out y prime, brought the other stuff to the other side. And now that's actually not the question. We've done the derivative. We need to sub in our x value. So this is our first step. I'll start my second step over here, okay? So as usual, when x, ooh, this is a little different. When x equals -3, and we actually have a y value too. So when x equals -3 and y equals 1. Twist. We are given both. Sub in x value and the y value. So we've been given two things, x and y. Our question here, or our derivative, has x and y, so we put in both numbers. It might seem more complicated, it's really just an additional number. So we have the y prime equals -1 over 6, 1 squared plus -3. So our y prime is whatever this gives us, which when I calculate this, and you should do the same, -1 over 6 times 1 squared, so just 6 minus 3. I get -1 over 3. Good, so we're getting -1/3. Once again, I'm comparing it. I don't mean to write too much. Of course, anything I write in pencil, anything I don't write in my standard writing is just extra stuff to help you see the bigger picture. So when you look back on my notes, you should be able to walk through it if you're having trouble. But really, it's the main stuff that's important. So I'm just substituting in. Whenever I see y, I'm putting in y. And whenever I see x, I'm putting in x. All right, that's the big idea here. Questions before I move on? I'll try to do some review before we finish. I can do another one like this if you want me to. Some of you have been a little quiet. I hope you're doing okay. I've been under a little bit of pressure to make sure that the students are actually in the chat or are actually in the class. I haven't been enforcing that very much because it's difficult to enforce it, but yeah, just please, if you're there, write something in the chat every now and then. Let's see, I can do a practice. I'm in the home, not in the class. I see, okay. You're gonna be like that, are you? You're gonna be like that. Okay, I'm just on page 46. It's just a little example here. It's clearly, well, to you it might not be clear yet, but this question, it says it wants y prime. There's a y here and a y here, which means we need to do it implicitly. It means you can't solve for y first. So say, I can't solve for y prime before we start, so we have no choice. So let's just go ahead and get the derivative. This first one here is a product rule. I know that because it's an x and a y in the same expression multiplied together. So we do our product rule. So the derivative of the first one, 1 times the second one, y cubed, plus the first one times the derivative of the second one, which is 3y squared times y prime. The y prime is the most important part. That's the new piece, okay? And once again, first one, second one, f prime g plus f g prime. I don't know how many times I'm going to write that, but I hope it's going to stick in your head eventually, if it hasn't already. That's the first piece. And now what's the derivative of 3y? Well, let me give you a comparison. If it was 3x, it would pop out a 3. If it was 3y, it still pops out a 3, but we have to add a y prime at the end because that's how implicit works. So it's y prime, 3y prime, plus 2x, that's just this. That's an easy derivative. And then 9, well, that's a constant, so it gives 0. Now we have everything we need. That's our first step, the derivative step. Hopefully you're with me so far. The second step is to move everything to the right side, and I'll factor the left side. I can do that at the same time. I'm going to move everything to the right side. Let's see, anything that doesn't have a y prime. So a negative y cubed and a negative 2x. I'm just doing the right side first because it's easier. I'm taking this and moving it over. I'm taking this and moving it over because they don't have a y prime term in it. And that's what I'm looking for is y prime. I'll probably keep that there. It doesn't hurt anything. No, I'm going to take it. And then factor the y prime out of these. So I have, what do I have? I have y prime outside of, and it leaves this. You know, think of it as taking dividing the y prime out. It leaves this. So that's 3xy squared. Numbers come first, then x's, then y's. And then of the other y prime term, think of it as factoring the y squared out. So it just leaves the 3, so plus 3. So this is our factored version. I'll just put it over here. How are you doing so far, Juma? Is that making some more sense now? Juma. Okay, and now I'm going to divide by this. Why am I dividing by that? Well, because if I divide by this, it will cancel, and it will give me this. Normally, I don't write it out like that, but that's why I do it. It just cancels out that whole factor because I'm looking for y prime, and so I'll write down the clean answer here. As clean as I can do in my writing. Okay, that's our final answer. I'm going to move it over so that the equal signs are lined up. But yeah, should have just left it where it was. Okay, clear? I keep asking that, but I'm a man of, I have my ways. I have habits. I like to make sure that people have a chance. You're probably sick of me saying that too, but whatever. My life, my class, my rules. Okay, so implicit means we have a mix of x and y in the same side of the equation, and we're not allowed to solve for it first, so we just need to deal with it as it is. And generally, all that means is that it'll spit out a y prime term every time you get a derivative of y, and just solve for that y prime. So isn't it y squared? Now, y squared. Yes. Squared. And squared. Yeah, sorry. That was, so anyone that missed that, of course, there's a square, which means I divided by a square. That's not some crazy math rule. That was me making a mistake. So thank you, Ahmed, for that. That was me being silly and not paying attention. The reason it happened is because it was kind of hidden by this y. That's how that's what I'm blaming it on. It was a little hidden. It's like a secret. What is going on here? Okay, so now that we've done that question, I'm going to go back. We'll do what's called higher order derivatives, and then we can do some practice. Let's do it. Let's do this. Let's go scroll back up. Okay, so that was page 43 that we just finished on implicit. Now this is page 44. Let's highlight. What is my computer hating? 44. Higher derivatives. Very simply, higher derivative means you can get one derivative, our first derivative. You can get another derivative of that, which is the second derivative. You can get another one, third derivative, fourth derivative, fifth derivative, sixth derivative, seventh derivative, 100th derivative. That's all it means. We can take the derivative of a derivative. So that's what it says. We may take the derivative of a derivative. It's called the first, and then the second, and then the third, and so on. And if you call them that, it's called higher. So it's like climbing a ladder. First derivative, second, third, fourth, fifth, sixth, seventh, eighth, ninth, higher derivatives. There's different notations. The most common are this: y prime, y double prime, y triple prime, and then y with a bracketed 4 on top. Notice that it's not y with a 4 on top because that would be y to the power of 4. It's y with a bracket 4 on top. So the most common are these and these. Okay, the ones in the middle you'll see sometimes, but not so much in this course. So let's do these, and you can see that these are some of the easier topics, actually, the higher derivatives. So an example, this example here, it says find the higher derivatives for this function. It doesn't tell you to get first, second, third, fourth, fifth. It just says find the higher derivatives. And we're going to see that if we do enough derivatives, it goes to 0. So I'll say go until it becomes 0. Just keep going until it becomes 0. And I have a feeling looking at this, probably going to take us 1, 2, 3, 4 times to do that. Okay, is this question an implicit function? Because that's an important piece. Is this going to be implicit when we look at this and try to solve it? Is it implicit or not? It's a yes or no question. Is it implicit or is it not implicit? We're all quiet today. It's not implicit. And I know that because this is all x, which is good. Not implicit. It's just direct. It's called explicit. It's all x values, which means we can get our derivatives very simply. So we want the higher derivatives. Just as a reminder, the higher derivatives are y prime, y double prime, y triple prime, y quadruple prime, and so on. So what's the first derivative? It would be 15 x squared minus 2. Easy peasy lemon squeezy. First derivative. Second derivative, y double prime, 30x. Third derivative, y triple prime, 30. Fourth derivative, 0. Halas. Why don't we go further? Well, it's because, y to the power of 5, sorry, not the power of 5. Fifth derivative would still be 0. Sixth derivative would still be 0 because once it's 0, the derivative of 0 is nothing. So we don't have a function to deal with, right? So we finish it at y equals y to the power of 4 equals 0. Y fourth derivative is 0 is what I meant to say. That's what I meant by go until it becomes 0. Let's try again. Let's try a new question, a little bit longer, but not too much worse. It says find the higher derivatives of this function. Now, I don't know if you watched Tom's video, but when he did it a different way. He did it exactly like it said. It said hint, simplify. In your book, it says simplify y prime, or f prime. Well, I'm not going to agree with that because I don't think that's what the book meant to say. I think the hint was supposed to be simplify the function first, because to simplify the derivative first doesn't make any sense. So when it says simplify, it means this, work this out. So let's simplify it. Well, the x times, and then we'll work out the square here. So square the first term, that's x to the power 4. Multiply them together, that's negative x squared, and double it, so 2x squared. And then square the last term. So really what I have, f of x, I'm going to distribute the x, it's x to the power 5, minus 2, x to the power 3, plus x. That will make life much easier. And in fact, by looking at this, I can tell I'm going to have to do the derivative 6 times. It's always one more than the power. Look at this. I had power of 3, it means I did it 4 times. If you have power of 5, it means you're going to have to do this 6 times. You don't need to know that, but it's nice to know some tricks as to how long you're going to spend doing these. Okay, let's do these. I'll do them slowly. You can do them yourself on the side of the page or on your page, and we can compare them. I'll just call it y prime. Well, it's in function, so I'll write down the function. F prime. 6, oops, I already made a mistake. 5x to the power of 4 minus, what's 2 times 3? 6x squared plus 1. All right, I'm going to do it again. I'm just going to write them out. I'm going to stop talking to give you a break. But you try these as well. See if you agree with me or not. I might make a mistake. We'll see. How's that? Same? So you said it was easy. I agree that it's easy, especially for ones that are polynomials, which means you just have something like this, right? That's a simple polynomial. If you hadn't had that hint, I think sometimes students do something a little crazier. So let me just show you, if you didn't have the hint, you would have to do this. You'd have to do the product rule, which would be the derivative of the first one times the second one, plus the first one times the derivative of the second, which would have been 2, keep the inside the same, and then the derivative of the inside, 2x. And then what it says is it wanted you to simplify that. So we could go one step further, and it would have been this. I just want to show you what the book wanted you to do. It wanted you to simplify this, which would have been this. 2 times x times 2x is 4x squared. X out of x squared minus 1. And it wanted you to work with this for some reason. And it would have gone one step further, and you would have had 5x to the power 4 minus 6x squared plus 1, which if you're very keen, if you're paying close attention today, you'll see that this is this. Why would you bother not to expand it first? It's way easier. So if you can, if you only have small powers, which I mean, if you only have a power of 2 as your highest power, it's almost definitely in your benefit, or it's a good idea to expand first, because it'll make your life much easier. If you don't expand first, you end up with this, and that is not what I would call easy, okay? So hopefully that's making some sense what I'm saying. I'm not trying to overwhelm you, just trying to give you 2 ways to do this. So this was an or. On a scale of 1 to 10, how's things going for this topic so far? I'd like you to reply. If nothing else, then this will be my attendance check of the day. If you're still with me. So Nasser still with me, Abdullah still with me, Aisha still with me, Yuma, Abdulaziz is still here, Ahmed is still here, Al-Sadeg is still here. I'm looking for, Ahmed Al-Naim. No Tarek, no Noran, no Ahmed Al-Asad. Oh, Tarek, coming in hot. Yasmin, questionable. Noran, questionable. Ahmed Al-Aswad, questionable. This is the secret test, right? It comes in the middle. Who's there? Who's actually in there? What I've been told to do is kick you out. I'm not going to do that because I think it's mean, but I'm watching you. Okay, let's do another example. I'll evaluate the second derivative of this for x equals -2. So we need to evaluate. What evaluate means, substitute in the x value. We know that. We've seen evaluate before. It means take the x value, put it inside. The problem is, this function, as it is, would be really ugly to get the second derivative of, because it looks like a quotient. And if we do the quotient rule, you can imagine already you're going to have f prime g minus f g prime over g squared. You're going to have a big old fraction. You're going to have to get a second derivative of that, and that would be a real big pain. So what we're going to do instead, I've said the hint here, change the form first, which means you only see a constant on top, So look at this. You see that this is a constant? I'll make it in this color. This is a constant. It's easy to change form. So just look at this. Keep the 2 where it is. Bring the bottom up, 1 minus x, put it in brackets, and just add a -1 on top, because really this is a negative, this is a +1, or it's to the power of 1. Just bring it up top and give it a -1. That'll be way easier. The reason it's easier is now we don't need to use product rule or quotient rule. We can do chain rule. Okay, so if you notice that on top is just a constant, it's extremely easy to bring this up. In fact, even if it's not a constant, it's usually pretty easy. But now that we've changed the form, I'll write it out here again. Our form is 1 minus x to the power of -1. Once we have that form, we're going to use chain rule. It means bring the power down and everything. And if you're not sure, this is y equals 2x to the -1 form. So y prime is, bring the -1 down, it multiplies by 2. Bring it down, subtract 1. So that becomes -2. Keep the inside the same. Reduce the power by 1, which is -2. -1 minus 1 is -2. It's already negative. You're making it more negative. -1 minus 1 is -2. And then we need to do the derivative of the inside, which is -1. So the derivative of this is this. Okay? Let's simplify that because it's pretty easy to do. We just multiply this by this, which is +2. The reason I'm simplifying it first is because otherwise it's going to be difficult to get another derivative. Okay, I'm actually not, I'm not finished there. It says the second derivative. This is just the first derivative. We'll make a note here. This is the first derivative. Okay. Hopefully all my extra notes aren't throwing you off. I'm trying to make it easier, not harder. So just tell me if it's getting confusing. Now that I have this function simplified, I'm going to get another derivative in the exact same way. The exact same way. It's in the same form. So the second derivative, I bring the 2 down, multiply it, it becomes -4. Keep the inside the same, still 1 minus x. Reduce the power by 1, so -2 minus 1 is -3. And then get the derivative of the inside, which is still -1. And I'm going to simplify that. So once again, it's -4 times -1. It's going to be +4. And now I have my answer. That's my second derivative. I'm going to say evaluate for x equals -2. What's its value when x equals -2? Y double prime when x is -2 is 4, 1 minus -2. Let me make sure that this is clear. My computer is very slow. Maybe it's because I tried to install some video games on it yesterday. Sea of Thieves just came out on Steam, and me and my wife have been playing it in our downtime. Maybe that caused some issues, I don't know. 4/27 is our answer. So the value of the second derivative of this function is 4/27. It's also 0.148. If you're wondering what the slope is, it's a very slight slope. -32, how'd you get -32? Did I do something wrong? Or did you do something wrong? Very possible that one of us did something wrong and it could actually be me. I hope not, but it's possible. Let me check my other notes. Which page are we on here anyway? 45. I got 4/27. How'd you get -2, Tarek? Did you Maybe put something in your brackets wrong. Maybe I'll just assume that I'm not going to hear back. I think 4 over 27, I think is the correct answer. I'm looking at my old notes. I think it is as well. I want to make a note here. So yeah, just check your work. I want to make a note that this, some students also write this as y equals 4 over 1 minus x. You can bring it back down on bottom and make it cubed. It's the same thing. So you could also say 4 over 1 minus negative 2 cubed. And that should definitely, that's where that 4 comes from on top, and on bottom, it's 1 minus negative 2, which is 3. So 3 cubed gives 27. So I think I'm right. But it's important to be able to find your own mistakes wherever they are. When I get to the end of the units, it always goes slower because the computer can only handle so much. Okay. Let's keep going, unless you have an issue with this. We're okay to move on? This is the last actual example question, and the rest will be practice. And if we don't want that practice, we can always move on to the next topic, but I think practice is a good idea. Okay. I'm going to move on, and if you need to go back and see what I've written there, you tell me, okay? Let's see what else this question has in store for us. Find y double prime, or the second derivative, for the implicit function defined by this. Why is it implicit? It's because it has a y in the middle, and we wouldn't be able to solve for it without like a plus or minus square root. So we need to solve for it directly. We have a y is mixed up into the function. It's not y equals. Right? It's not in the form y equals. That's what it means. So let's get our first derivative. First derivative. I'm gonna say 4x. That's the derivative of this one. Plus, what's this one? Bring the 2 down, multiply by 3, we get 6y. Reduce it by 1, okay? Y prime equals 0. Same story once again, right? Bring that to the other side. Bring that 4x to the other side. So it's going to give me 6y, y prime equals negative 4x. I'm going to divide both sides by 6y. They'll cancel. So that means y prime is negative 4x over 6y. That's my first derivative. I need to get a second derivative. If you've been following so far, you probably have a pretty good idea of what's coming next. If that's our first derivative, let me just split this up now. How do I get my second derivative? We only have a couple rules. We have power rule, we have product rule, quotient rule. Negative 4 over 6. Sorry, what's... Oh, yeah. Let's make life easier here. I think you're trying to tell me to simplify this. Probably would have been smart. Okay. That's what you're trying to say, right? Or did you type that before I did this? Yeah, thank you. So yeah, no need to keep it the way it is. I should have simplified that. Thanks for that. And second derivative, you should hopefully notice that this is a quotient. So now we use, I'm going to use the quotient rule. What's the quotient rule, you might ask? I hope you're not asking it because we've done it probably 10 times now, maybe. FG, but we've got our subtractions. Prime at the first and last, Q prime on bottom. So let's work it out. Y double prime is the derivative of the top, -2, times the bottom, 3y, minus the top, and the derivative of the bottom. 3 would be what it would normally be, but y prime is in there as well. Divided by the bottom squared. Okay, we have a little bit of an issue here because this is ugly. We're actually going to have the second derivative in terms of the first derivative, but that might be okay. That might be okay. Let's see what happens. Let's simplify. I'm going to simplify now. Y double prime is -6y plus 2x 6x y prime over, if you don't know how to do these squares, this is 3 squared y squared, 9y squared. Okay, I'm a little bit stuck here. We have a bit of a problem. Does anyone know what this problem is? This is an ugly question at this stage. We have an issue. How do we go any further? We don't have any common factors. Well, not really. I kind of have a common factor of 3. There's a lot of y, but yeah, look at this. We're looking for y double prime, so that's okay. That's already solved on the left side. But look, we have a y and a y. They can stay the way they are. We don't need to touch them. The problem is that we have this y prime. But we know what y prime is. It's this. So I'm going to substitute. So to get from here to here, I simplified. To get from here to here, I'm going to substitute what I know for y prime. I'm going to keep everything else the same. 6x, what's y prime? Y prime is -2x, so over 3y. And that's over y, 9 y squared. And that's it. I'm just going to simplify and I'll be done. I know I need to simplify because these are basic numbers being multiplied, 6 times 2 divided by 3, things like that. So I'll go term by term. I'll do the first term is -6y. Okay, that's fine. Second term, I'm going to multiply 6 by 2 and divide it by 3, which is 4. If you don't believe me, put in 6 times -2 divided by 3 on your calculator. You'll get 4. So minus 4 x squared over y. And on bottom, 9y squared. We don't need to go any further than that. I'm not even going to show you what I would simplify it down to because I don't want to confuse you. But that's the big idea. So I would call that challenging. First step, first derivative, very straightforward. Second derivative, tricky, which is why I made sure to review quotient rule yesterday. I want you to be clear here. So this is your time for questions. How are we feeling about that? Abdullah, I think you're always fine. Very hardworking. Anyone else? Not that you're, okay, let me rephrase that. Abdullah's hardworking. I believe that most, if not all of you, are all hardworking. I didn't mean that in a bad way. But for some people, math comes easier. For other people, math does not come easy. I've told many of my students that when I was in my last year of math in high school, I was failing for a while. And it was mostly because I think it was mostly because I had a bad instructor. I was also very easily distracted. But this stuff doesn't come natural to a lot of people, most people. So don't be afraid to tell me at some point if you are having trouble. You can tell me personally, you can send a personal message to me, I don't mind. Just let me know so I can.
Actually, I finished this topic in high school.
Yeah, so you're already have an advantage, yeah?
Yep.
Yeah. So see, we all have our secrets. our cheat codes. Okay, so, let's move on. This is probably the hardest example. I don't think I would give one quite this difficult on a assignment or a test, but the basics, the pieces shouldn't be hard to follow. We're still just getting the first derivative. We see a fraction, so we had to use the quotient rule. This last substitution step, I think, was probably just a weird one, but the rest, hopefully okay. So practice. I don't know how I feel. If I want to do the practice, maybe I can take one or two practice questions. Maybe, I'm just scrolling down looking for what I think would be a good practice question. I'm going to do 6 because the other ones, you could look at these solutions yourself. I'm going to do 6, and then I'm going to actually start the next topic. Even if I don't finish it, I want to get it started. So let's do 6 on page 47. And of course, there's nothing wrong with the rest of the questions. I'm just trying to focus on ones that I think are very fundamental to figuring out how to do this stuff. So what is the second derivative of the function p of x, where p of x is x minus 2 over 3 cubed? Second derivative. So we need y double prime. So in order to get y double prime, we need to get y single prime. We need to get the first derivative. First things first, you should look at this and you should already be getting used to the idea that we can change the form, and we should. Write this, rewrite it as 2 x to the power of negative 3. Bring the x up, make it negative. Make your life easy. I'm just saying, make life easier on yourself. If you don't do that, you'll force yourself to use a quotient rule. And why would you want to do a quotient rule? The power rule is way easier. So just always assume you can do it by the power rule first and then worry about quotients. So I guess I need p double prime, but it's all the same. I need p double prime of x. So p prime, first derivative, is, well, let me write the function here so that we can compare it. Some students don't like to look across the page, me being one of them. So the first derivative is 1. Negative 2 times negative 3 is 6. X to the power of negative 4. Okay, see how easy that is to get the first derivative? If you had to do the first derivative with the quotient rule, it would be way longer already. So don't waste your time. Simplify first. That's our first derivative. Our second derivative is going to be just as easy. The derivative of 1 is 0, so we don't write it. We take 4 times 6, 24, positive, and negative 5. Done. That would be the final answer. Or, my famous or, which means an equally good answer, would be this. So that's my second derivative. Of course, it's kind of written weird. It's saying at the point 4 and 127 over 32. So I'm going to substitute in x. So substitute in x equals 4. So the second derivative when x is 4 is 24 over the 5th power of 4, which is, I feel like I've lost a negative. Have I lost a negative? Yes. In the beginning here, I made a big mistake. I think, yeah, Ahmed actually brought it up. This is a positive, which means this is a negative, which means it's negative 3 over 128. Sorry about that. I'll make a note of that. This is negative, negative, and positive. Just be careful. I'm only human, as most of you are. I think some of you, depending on your marks that I see, I think some of you are superhuman. Maybe you have some special way to get the answers that you do. I'm sometimes very impressed by the solutions you come up with. But yeah, the final answer is -3/128. That's a nice difficulty question. It might be a little too easy, actually. I don't know if I'll ask one quite that easy on a test, but we've done ones that are similar difficulty. Let me see. I'm just looking at the practice here if I want to do one more. Let's see. Some of these are ugly. I don't like the ugly questions. I don't think students do either. Okay, I'm gonna move on, or let me ask you: do you want to do more practice on the sort of stuff we've been doing so far, or do you want to move on to the next topic? Just say practice. Next topic. So that's 3 people that want to move on. And if you don't vote, then I can't, I don't know what your opinion is. But I'm happy to move on, doesn't bother me. Okay, I'll move on, because who knows who's still in that chat. It's a mystery to me. I think some of you just watched the video after, which is fine. Okay, the next topic is actually, you're welcome, a topic we've actually already done. We haven't done the normal line, but we've done the tangent line. So you remember the steps. You get the derivative, you sub in the x value, that'll give you the slope, which is m, and then you go solve for b, and y equals mx plus b. That'll give you your tangent line. You changed your mind, you want more practice. What, because you're scared of this topic? It's just, I don't want to see it. It's too late, you've already voted. We can do more practice before the test. So the tangent line, 4-step process, well, 3-step process. To find the equation of the tangent line at some given point, let me highlight it. The equation of the tangent line at a point, first you find the derivative, second you evaluate the derivative at the point. It says it's either at x, you either put the x value in or you put x and y value in. It depends on if it's implicit. And then third step is to substitute the point in the slope point form. Actually, I would say that you're going to use y equals mx plus b, just to be clear. And this will be more clear when we do it. In my opinion, slope form is much easier. Sorry, y-intercept form is much easier. Slope-intercept form is much easier is what I'm trying to say. And we'll see that. So find the equation of the tangent line to the parabola x squared minus 1 at the point -2, 3. Okay, so if we zoom in on this, this is the function x squared minus 1. That is that curve. And it's saying we want the slope of that line at this point, -2, 3. We don't need the slope of the line, we need the equation of the line. And to get the equation of the line is different from the slope. The slope is just a number that tells us how steep. The equation is the full line that we could draw on the graph. Okay, so let's follow the steps. First step is derivative. Get the derivative of the given equation, which is very simple for this case, 2x. Second step is going to be evaluate x equals -2, because that was what was given in our question. So y prime when x equals 2, or -2, is 2 times -2, or -4. Our instructions on the previous page said that this value will give the slope of the tangent. So what this value gives us is m. You might remember this from earlier. So we know that this is our m value. We're going to put it in a box because it is important. It's not our final answer, but we're getting there. That's the slope of the line. That's the slope of the tangent line. We don't want the slope, we want the equation. So the third step and the final step is use y equals mx plus b to find b. Y prime is m, yes. Y prime at a given point is m. Y prime is the slope. Remember, y prime is the derivative, and the derivative is the slope function. So all these ideas are connected. So let's see what we got. I'll write out y equals mx plus b, and I'll highlight. Our x value is this x. Our y value is this y, and we need to solve for this b. Our m, oops, my computer hates me. This is our m, which is this. So we've done this before, so this is a good review. This is 3, -4, -2, plus b. So that means 3 equals 8 plus b. I can bring that to the other side. That means, what's 3 minus 8? It's minus 5. So I got the derivative. I evaluated it to get the slope, m. Y prime at that point is m, the slope. Use our y equals mx plus b to find b, and now I can write my final equation. Just write the equation of the tangent line. Y is general, x is general, m is -4, b is -5. Just so we're crystal clear, hopefully you can see that this is, oops, this is m, this is b. Halas. Now I'll do my favorite thing, which is graph it, because I know the graph's already there, but I want to show you how you would check your own work if you wanted to. I'll bring this back up for anyone who's still writing. So let's just say we didn't know what it looked like and we wanted to check our answer. So our function, our original function is y equals x squared minus 1. Okay, that's our graph. The point -2 and 3 is the point we care about. I'll zoom in a little bit. We care about this point, -2, 3. What we've just done is used derivatives to make the tangent line. So if I was to draw this freehand, I would probably say that the slope, the graph should look something like this. I'm trying to touch it only at one point. So it's something like that. It'll probably actually be a little more steep. But let's see how good our answer is. Y equals -4x minus 5. Okay, much better job. It saw the point that I'm talking about, this -2 and 3, and it's saying I'm going to draw a line that's tangent at that point. And you can see if I zoom in here, that it is definitely tangent. It's only touching at that exact point. No matter how far I go in, it's not next to it. It's touching exactly. It's just drifting on and touching it just at that point. Okay? You can see it's tangent. That's what we did. We made the tangent line to the original curve. Original curve, tangent line. Okay, so hopefully you're making some sense of these ideas. You're making these connections yourself as well. I'm trying to make it all clear to you. Some of you don't like to know about the graphs, but knowing the graphs as well is what makes this interesting, in my opinion. And of course, the later you go into engineering, hopefully you actually get to use some of this stuff in a more interesting way. Okay, we're going to do another one, assuming that this one's okay, and I will trust you to write it in the chat if it's not okay. Find the equation of the tangent line to the ellipse. Oh my goodness. Find the equation of the line tangent to the ellipse at this point. Well, right away, when I look at this, that should scream implicit. It screams implicit because the y is in the middle. Not a big deal. It just means we're going to get y primes. We're going to get y primes come out of this in the middle. Okay, so the first things first, I'll write out the same steps. First thing we're going to do is get the derivative. And the function is, the original function is this. You can go ahead and do this yourself. If you know where I'm going with this, if you haven't already, try to do this yourself. So the derivative is 8x plus 18y, y prime, equals 0. And again, that y prime is our implicit piece. I need to keep solving for y prime. So I'm going to bring the 8x to the other side. Becomes negative 8x. And then I'm going to divide both sides by 18y. You can skip that step with the pencil. You can jump straight to this step here. 8 divided by 18, it can of course be simplified. That's 4 over 9. I don't know why I use a calculator for that. I'm a little bit ashamed of myself. Negative 4 over 9. Negative 4x over 9y. Make it clear. And that would be my derivative. My second step, what do? Well, if this is my derivative, then when I evaluate it, or substitute in my x and y, in this case, I have 2 because it's implicit. I will get the slope. So it's like Abdulaziz said earlier, the y prime, once I evaluate it, it is m. So y prime is negative 4, 1 over 9, 2. Y is a slightly different point, of course. And that gives negative 4 over 18. So negative 4 over 18 would be negative 2 over 9. So just give you a chance to catch up if you haven't gotten this far already. That's our slope of our tangent line. That is not our final answer. A lot of students stop there. That's not the equation of the line. The question asked, find the equation, not the slope, the equation of the tangent line. So we have a third step. So our third step, just like we did earlier, is to use y equals mx plus b. Let's put in our values. Oops. Actually, I'll write this out. Y equals mx plus b. What's our y value? It's negative 2, or sorry, positive 2. Our m is negative 2 over 9. Our x is 1. Our b, we don't know it, but we can find it. So that means 2 is negative 2 over 9 plus b. So if you rearrange that, bring the negative 2 over, it's 2 plus 2 over 9. 2 plus 2 over 9 is 20 over 9. So this is 2 over 2. Or 18 over 18. Let me see, that looks okay. And so my final answer, y equals mx plus b. In this case, b is 20 over 9, so 20 over 9. Okay, how do we feel about this one? Easy peasy. It will suck. What's Edlutzak? Is that something that, does that mean easy in Arabic, or did you make a typo? Sorry, I have a really bad back. And so every now and then I need to stretch, lest I become paralyzed. So let me go and graph this for you, because this is my favorite thing. I at least like to have a little bit of fun with this stuff. And by fun, you know, fun is relative, of course. B equals 1.8, 20 over 9. I don't think B is 1.8. 2 minus 2 over 9. It's 2 plus 2 over 9. Because it's negative on the right side of the equation, but we brought it to the left side, which changed the sign of the B. Yeah. Sorry for anyone watching the video, you're not going to know what I meant, but there was just a question. So let's do the same thing. The function. The nice thing about Desmos is it can take implicit stuff. So 4x squared plus 9y squared equals 40. So it's an ellipse. It said it was an ellipse, which is a good thing. 0.12. So it wants the tangent at that point. And you could do this yourself. You could check your own work. Go to draw. I'm going to have, can I make a line here? That's my freehand. That would be my guess at the line that I'm going to get. I don't know if I'm going to get that because I just did it by hand, but that's pretty close. I have a feeling maybe it'll be a little bit more down. Let's see. Y equals negative 2 over 9, x plus 20 over 9. I was wrong. I was close, but that's actually the real answer. So not bad. Not bad at all, if I do say so myself. And we can see that that is indeed a tangent at that point. If I zoom in, it's only touching at that 1 point, 1, 2. It's coming down, kind of like an airplane comes down on the runway, just taps it, and then moves on. You know, if it was under bad conditions or something, I don't know. Just a little touch. That's how we do it, folks. Let's see what else there is. I might even finish more than I expected today. The normal line. My goodness. We're gonna have to do normal line. Okay. I don't know if you have any instructors that talk like that. In Newfoundland and Labrador, we have our own accent. We have our own dialect. So sometimes you get professors or instructors that talk like this, and you don't even know what they're talking about because all they're saying is all mixed up, right? But that's the way they talk in Newfoundland and Labrador, so you got to get used to them, right? But you always know when you got a person from Newfoundland because they talk like this, and you're like, oh my God, what is he even saying? Yeah. So people from Newfoundland and Labrador don't talk as clearly as you might expect. It's Old English. So what's the normal line? Does anyone know what the normal line is? I've got the definition here, but has anyone dealt with the normal line before? No. So some of you I know when I first talked about tangent lines, you didn't know what that was either. So it's very similar. It's kind of like the opposite of the tangent line. So you'll see here, we have three things. We have our original curve, which is in red. So this is our original curve. Our tangent line is going down, touching it just a little bit, and moving on. Our normal line does kind of the opposite. It is perfectly perpendicular to the tangent line. So you'll see that the tangent line and the normal line are at right angles to each other, 90-degree angle. That's the big takeaway for this. So the process is exactly the same, except we need to do something about this perpendicular. So it says on bottom here, the normal line to a point on the graph is the line that is perpendicular to the tangent line at that point. So if we have a line like this, the normal line will be perfectly perpendicular, right angle to it. Since perpendicular lines have slopes that are negative reciprocals of each other, we just use the slope of the tangent line to find the slope of the normal line. So let's look at the steps. The first step, find the derivative. Same. Same as before. Second step, evaluate. Same as before. Third step, new. Find the negative reciprocal of the slope. It just means make it negative and flip it upside down. That's all it means. It means make it negative and flip, or change sign and flip, and then substitute the given point in. That's the same. So I'll do one example on this because it might be nice to have a little bit of a break today. Maybe finish earlier than normal. And I know it's getting late in the semester, so I don't want to overwhelm you too much. One, maybe two examples depending on where we finish. I'll try to finish soon. So it says find the equation of the normal line, normal to the hyperbola. Find the equation of the line normal. So really the keywords are equation and normal to the hyperbola at this point 2, 1. So since Desmos is already up, actually no, I don't even need to look at the equation. I can just do this. First step, sorry, I was going to graph it. I don't need to look at the graph. I can just do it directly. So the derivative, if y is 2 over x, what's the first thing we should do? Just a little check to see if you're still paying attention. What's the first thing I should do here? I should really change the form. Yeah, thanks, Tadek. You should change the form to be 2, bring the x up. I'm going to say, let's not use this. Let's use the change of form. And then once we have that, we'll start doing the derivative. Y prime, that's negative 2 to the power of negative 2. All right, very straightforward. Second step, substitute in our x value, in this case 2. So y prime, when x is 2, is going to be negative 2, 2, power of negative 2. Lots of 2's. So what's that? That's negative 2 over 4. So I think it's negative half, if I just did that in my head. But negative 1 over 2, that means our slope is negative 1 over 2. So again, that's not the equation, that's the slope. The slope of the tangent at that point. The point 2, 1. Third step, and that was very important, this is the tangent, not the normal. The third step is called the negative reciprocal step, which means if m of the tangent is negative 1 over 2, let me split this up. If n of the tangent is negative 1 over 2, then m of the normal n is, make it negative and flip it. Make it negative, so negative 1 over 2. Make it negative, so change the sign, and flip it, 2 over 1. So it's 2. So that's the slope of the normal line. You just literally turn it upside down, change the sign. So I don't need to keep this extra work here, hopefully. That's our new step. I'll make it a different color just so that you know that there's something different about this question. Oops. Sorry, sometimes technology doesn't go according to plan. And then 4, I'm going to use our last step, y equals mx plus b. All right, we're in the home stretch, everybody. Let's split this up. We know that y equals mx plus b. Our y value is 1. I don't need the brackets, actually. 1. Our m is 2. Why is it 2? Because it's the m of this, not the tangent. Our x value is 2. We're looking for b. So that's 1 equals 4 plus b. If you solve that, it's 1 minus 4 equals b, which is negative 3. Now that we have this, we can sub in all of our information and get our final answer. Y equals 2x minus 3. So while you finish writing that down, hopefully you're writing it down, I'll graph it, and that'll be all we do for today. We can end a few minutes early. Lots to think about. So the original function, it tells us that it's a hyperbola. My computer. Goodbye, 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 goodbye. The original function is y equals 2 over x. So it's this crazy looking thing. The point that it wants us to look at is 2, 1, so it's over there. So if I had to guess, I would say the tangent line looks something like, oops. Let's make a good tangent line. No, I think I'm probably not doing a very good job. Let's see. I'm gonna guess that. That would be my guess for the tangent line. And then, so the normal line would be something like this. I really want that line. Let's see how close I am, and I'll free you from my shackles. Y equals 2x minus 3. Whoa! That was so close, I want to go and eat a chocolate cake. I feel good about that. That's the normal line. You'll notice, or at least you should notice, that if we zoom in on this, the normal is perpendicular to the original function. It's perfectly 90 degrees from the original function. That's what we found, okay? So we get the curve, get the slope of the normal to it, and get the equation from that. Okay, so that's all I have for you today. We've done a lot. We actually only have one topic left for the whole unit. So what'll happen probably is that I will finish the unit early tomorrow morning, for those of you that are watching this live, obviously, early in tomorrow's class. And then I will do maybe a practice assignment, which I almost never do, but I thought maybe it would be nice. How's that sound? Is that okay? I'm going to stop the recording here, and any questions you have, you can let me know. See you later, everybody. Like and subscribe.